Always striving for harmony between people and machines, Omron has developed a concept model of a ping-pong robot capable of continuous rallies with a human player. This model balances precise rotational speed estimation and real-time responses to accurately predict the ball's trajectory. The margin of error between the calculated value of the instant the ball will reach the robot and the actual value is but a few centimeters. When the human player strikes the ball, the robot starts calculating its response based on as many as 80 factors per second. Two cameras in the upper portion of the machine track the ball's position and velocity, then use its trajectory, curvature, and deceleration to estimate rotational speed. At this point, the robot makes an instantaneous analysis which takes the Magnus effect, a phenomenon which affects drag and lift of the ball, into account as well. The robot uses Omron's proprietary prediction model to instantly process massive volumes of data and predict the next movement of the ball. The ping-pong robot also assists the human opponent, boosting the player's motivation and skill. Once the rally has started, the robot memorizes the trajectory of the ball hit by the human player and considers the easiest location for the player to hit the ball. Conversely, it also uses trajectory prediction to consider the optimal point for itself to hit the ball and estimates ball speed, rotational speed, and rotational direction. Based on those results, it determines paddle angle, as well as the location and timing of travel by the paddle through the midpoint. It controls movement using 5-axis motors, which faithfully reproduce those movements. At this point, the robot assists the human player's next move by displaying a spot on its side of the ping-pong table to indicate where the return ball will land. This makes it easier for the human player to adjust the timing of his response to the ball and improves his skills. Ball detection, trajectory prediction, movement calculation and control, and provision of information to the human player are all performed within a fraction of a second using Omron's technology and existing factory control equipment. This successful integration of sensing and control plus think can be utilized in robots which support human activity, like at workplaces facing labor shortages. Through detection and prediction of location and movement of goods, control of the movement of the robot itself, and real-time provision of information to workers, we can improve the working environment surrounding production processes in factories. We anticipate that in the future, the technology incorporated into this ping-pong robot will be used in such settings. Machines can do much more to unleash human potential. Omron.